Today we're going to use the method of substitution to solve linear systems of equations. So the substitution method functions by substituting a solved variable from one equation into the other equation. So let's just go ahead and get to it. So on number one, this is a system of two equations, and we're going to use substitution. So here are our steps. Isolate a variable in one of the two equations. So get a variable by itself. Look at your two equations. What I'm noticing here is the second equation already has a variable isolated. Its variable that's isolated is x. It's all by itself over here on the left. So that's good. We're good with that step. Step two, take the expression that is equal to the solved variable. So this is the expression that's equal to the solved variable, and substitute it into the other equation. So what that means is where I see x, since this is what x equals, I'm going to plug in this. So it's very similar to composition, okay? When you complete this step, you should have only one variable. It can repeat, but it should be the same letter throughout the equation. So let's see if that happens. So if I take this, what x equals, and I essentially plug it in where I see x here, since it says x equals this, let's see how that would look. So I would have 2y equals, where I see x, I'm plugging in y minus 4 plus 7. Okay, so it said when you complete this step, you should have only one variable. It can repeat, but it should be the same letter. Yes, the only variable I have now in this equation is y. Okay, it repeats, but it's just y. There's no x. Solve for the variable. Okay, so I know how to do this now. So out here in parentheses, I've only got a number 1. If I multiply 1 times y, 1 times negative 4, is that going to change? No, it's just still going to be 1y negative 4 plus 7. So let's clean this up. Before I start moving variables one side, numbers to the other, I can combine these two like terms. So this would be 2y equals y plus 3. Okay, so now I need to get all my variables on one side. So I'm going to go ahead and pick the left. I'm going to subtract y. 2y minus y is just y. Those canceled. And I have 3. Okay, so solve for the variable. Check, I did that. I've got y equals 3. Once you have found a solution for one variable, substitute that value back into one of the original equations and solve for the other variable. Okay, so I can pick either of these two equations to plug y equals 3 back into. Well, this one's going to be the easiest because x is already by itself. So if I take y equals 3 and I plug it into this original equation, so x equals, where I see y, I'm plugging in 3. Okay, so here when I plug in 3, it's just like 3 minus 4. There's nothing that I need to multiply by. So x equals 3 minus 4, which is negative 1. So that means I have found my coordinate where these two graphs, graphically, where they intersect. So I need to write it as what it is. It is a coordinate. It's an ordered pair. That point, negative 1, comma 3, is exactly where those two lines intersect. Okay, let's try another one. Of course, you know we got to make it a little bit harder. So here, starting over at our steps, isolate a variable in one of the two equations. Get a variable by itself. So not so lucky here. We don't have a variable that's all by itself. X and y are both on the left. They've got numbers in front of them. This equation is messy. Don't even want to mess with that one. Look at this equation. Okay, yes, there's not a variable by itself, but it would be real easy to get a variable by itself. I could either get y by itself or x by itself. Here's the issue. Notice, if I get x by itself, I'm dividing by 2, okay, which is fine, but when I come over here and divide by 2, that's going to be a fraction, that's going to be a fraction. No way, don't want to deal with that. So instead, I'm going to choose to get y by itself, because all you'd have to do to get y by itself is move the 5 over. Okay, so this equation would essentially become y equals 2x. What would happen to the 5? It would turn negative, right? When you move it across the equal sign, it turns negative. All right, so check. I've got one variable all by itself, y, all by itself. Take the expression that is equal to the solved variable, okay, so that's this, okay, and plug it in, substitute it into the other equation. So here I'm taking this because this is what y equals, and I'm going to plug it in where I see y into the other equation. So let's rewrite. I would then have negative 3x minus 4. Where I see y, I'm plugging in 2x minus 5. Okay. Where I see, I don't know if I said x, I meant y. Where I see y, I'm plugging in 2x minus 5 equals negative 2. Okay, now from here, PEMDAS, right? You have a lot of cleaning up to do on the left. So before I can start combining like terms or anything like that, I need to distribute in. So I've got negative 3x minus 8x. That's going to turn to a positive 20 equals negative 2. So now I've got these two x's here. I can combine those. So negative 8 minus 3x is going to give me negative 11x plus 20 equals negative 2. Now I can start getting that x by itself. Minus 20 minus 20. So that goes away. We've got negative 11x equals negative 22. So divide by negative 11, both sides. X equals, when I divide negative by negative, I get positive, so that would be positive 2. So now that I've solved for one of the variables, I can take what that equals and plug it into either of the two original. So again, that one's quite a bit more crazy of an equation than this one. So I'm going to choose the second one. It doesn't matter which. You could choose the first one and we'll get the same answer. So I've got y plus 5 equals 2 times x. Well, x is 2. So there you go. Y plus 5 equals 4. Okay, to get y by itself, I need to minus 5. So y equals negative 1. So the coordinate of intersection, make sure you write the x first, 2, negative 1.